These are section 3.1 notes, page 2. We're going to look at this graph again, but in a slightly different way than we did the first time. The function is the same, and if you take a look, we have a tangent line. This one is the tangent line at A. That's the one we're interested in. We also have a secant line here, and that goes, this is point X, so we'll put f of x up here, and at point A, we'll put f of A here. So really the only difference so far is that this was B before. We were looking at a secant line between A and B, so now we want to just look at between A and X, just a little bit different notation. And we talked about using the secant slope as an approximation of the slope of the tangent line. Okay, and let's just recall the slope of the secant using our basic slope formula here, and using the points A and X. It's going to be f of x minus f of A all over x minus A. Change in y over change in x. The slope of the tangent line to this, if we think about what we did last time, remember last time we had the difference in the two values was h, and we let h get really, really small. We want to do the same thing here. We want the value of x to approach a. So our limit notation for that, we don't need a new variable h. Let's let x get closer and closer to a, so that second point here on the secant line gets closer and closer to point A, ultimately ending up at the same exact point. So we need the limit as x approaches A of the same thing as the slope of the secant, f of x minus f of A all over x minus A. So it's very similar to the formula we were using before, where we wanted h to go to 0. The denominator was going to 0 before. And if you take a look, as x is approaching A, the denominator is still headed towards 0. Okay? These are called, this is basically a new formula that we can use to find the derivative or the slope of a tangent line at a point. And it's one of our 3 standard difference quotients. Let's recall the ones that we had. We had f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. That's the one we've used so many times. This is the one that gives us an equation of the slope of the tangent line. I'm going to jot that down. This gives the equation of the slope of the tangent line. At any point. Sometimes all we want is the equation. We don't need particular values. Maybe we want to graph it or whatever. But that's what that provides. The next version that we had, that we've already used a bit, f prime at A, where A is a particular point that we're interested in. And it looks very similar to this last one, the limit as h goes to 0. But instead of x plus h, we have the function a plus h minus the function of a all over h. And then now our new third one, f prime of a, because we have a particular point of interest a, it's equal to the limit as x approaches a of f of x minus f of a all over x minus a. These two are both used when you want to find the slope of the tangent line at a particular point A. You want to find the slope of the tangent line. Put those words together. The tangent line at a specific point A. Okay, those 3 standard difference quotients you definitely need to know. So we're going to put a box around that, make it flash. as I was off the page.